The following program is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Hello and welcome back to Element 14 Presents. I'm Matt, and you may remember Project Caroline here. This was our Raspberry Pi pirate radio station we built a few weeks back. Well, I was thinking of taking the same RF principles and just kind of beefing them up, making them bigger, badder, and possibly even be able to pick up some signals from outer space! Yes, we're going to build a satellite receiver. We're going to build not just any satellite receiver, though. We're going to build a portable unit that's encased, sort of a field deployable satellite unit that's going to be able to pick up NOAA's polar orbiting weather satellites and give us some cool pictures. So, let's get started.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
So receiving signals from a satellite is actually, it's pretty simple. It's tedious and it requires a little jiggery pokery, but it's actually a fairly simple concept. See, you have a satellite and it is just constantly broadcasting out an FM signal. So it takes pictures and it translates those images into an audio waveform. And then that is actually broadcasted on FM. So then what we do, it's a lot like sending and receiving a fax. So we have an antenna that picks up that radio signal, brings it over here into an SDR, and then that is going to translate that radio signal into an audio signal. So the audio signal picked up by the SDR, processed by a Raspberry Pi. So Raspberry Pi then takes that audio signal and turns that into a visible image. So if we hook up a screen to that Raspberry Pi, then we can see our image. That's essentially how this works. So we're going to have to build an antenna in order to pick up our radio signals, and then we're going to need this. We're going to need an SDR on a Raspberry Pi. We'll need a screen, and the idea then is to just build it into a handy little box so that we could carry it around. So Element 14 has these nice Duratool cases, and in the lid you're going to have the screen, and then down here in like the case part we're going to have some kind of power supply. We're going to have our Raspberry Pi and the SDR, and then I think I'm going to put maybe a keyboard in here, some kind of HID, some kind of human interface device. That way this will truly be a self-contained unit. And then probably some blinky bits, some blinky lights, maybe some status lights or something like that. I like blinking lights. And then we have our antenna in, power in. That's the basic design. So let's go ahead and start working on our radio and our antenna, put that together, make sure we can get a signal, and then we'll put everything together inside the case. The first thing we need to do to set up our Raspberry Pi SDR module is to install the USB drivers for the actual SDR dongle that we're going to use. And since the software for it will also be written in C, we're going to need CMake. Now we've got to make sure that the kernel doesn't actually activate any of the drivers or modules that would interfere with our SDR. Sudo nano. Alright, now we need to install the software for our SDR. So we're going to git clone. Okay, cloned, and then we're going to run CMake. C compilers run. Fantastic. Now we just run make. This will make our install file. Now sudo make install. And that's done, so reboot. Next thing we need to do is we just set up our ground station here. Station call sign 23 Bravo. Station latitude Now, I'm getting the latitude and longitude from Google Maps. That's just as easy a place to get it. Okay, so station latitude is at 33-87, and then this is in degrees west. So west is positive in this because east is least and west is best. So the last thing we got to do is put together a few scripts to really just automate the processes of finding out when the satellites are flying overhead, turning on the recording, and then setting that recording to process into an image. So we have a few scripts that'll do that for us. The first one is this schedule all script, and all this is doing, it's downloading the satellite information from the Predict software as far as the timing of the passes, and it's just setting that to schedule those particular recordings. Then we have the schedule satellite, which what this is doing is going to take each individual satellite pass, determine if it is an elevation of at least 20 degrees, because anything less than that, you're really not going to get a good signal and you're not going to get a good image out of that. So it's not even worth doing. We're going to take anything that's above 20 degrees and then we're going to create a schedule around that so that we know when to start and when to end the recording. So for the time that the satellite is going to be overhead. Last one that we need to look at, this is receive and process satellite. So what this is doing is it's actually taking each of the satellites, the relevant metadata for each of those satellites, and then processing the wave file into an image file with a particular file name based on the satellite and what time it came through. I want to pick up satellite signals from a polar orbiting NOAA satellite. So what that essentially means is that we've got Earth, so North Pole, South Pole, and you have the satellite that goes over the poles, kind of like that. It just keeps revolving over the poles as the Earth rotates. So it's doing this, the Earth is doing this. What it's doing is it's taking pictures and measurements and everything over a different area every time it orbits. So what it ends up looking like is, if you have your map, you basically have this path that looks kind of like that, and it does this as it goes across. What we have essentially is television antenna, and that's actually polarized a certain way. It's horizontally polarized. Rabbit ears on top of a TV doesn't actually work. If you notice, if you're an old school analog person like me, you'll notice that if you take the rabbit ears and you turn them pretty much horizontal, that's when you get the best signal. And because the rabbit ears are like 6 feet long, you end up having these two hunks of aluminum sticking out like this, and it gets in everybody's way, and you know, and your parents hate it, and they make you turn it the other way and put tinfoil on it or something. And I'm like, that doesn't work. That's not how it works, because I learned all this stuff by reading the encyclopedia, Mom. Anyway, so that's your TV signal. For this, you actually have a circular polarization. So the signal actually comes like that from whichever direction. What you end up having is this sort of helical shape that allows you to pick up signals from pretty much any direction. But essentially, you have a polarization, and then it runs down the middle, and then it runs out into your coaxial cable, and so you have just your element in the middle, and then your grounded sheath is actually the other side of the antenna.
So this is what the inside of a coaxial looks like. You have your, this is your shielded outer section, and then you have this inner core. And that's the part that plugs in. This is what connects to the screw connector on the outside. And it's separated by a little insulating layer right there in between. So we're going to connect a couple of our cables to the core, and a couple of our cables to the shielding.
So right here, I have stripped away some of the insulation from the RG6 cable, and I've wrapped the other 3 leads. This is the bottom of the antenna. You see, everything terminates right here, and the termination point on these 3 leads are going to be soldered to the shielding on the RG6 cable. And then the whole thing will go out to a BNC connector.
Okay, so our QFH antenna is very nearly assembled. Everything's wired, everything's put together. Last thing I gotta do is get this little BNC connector onto the end of the RG6 cable that I am using. I'm gonna want to solder that as it is, and then I'm going to want to wrap that in electrical tape and then solder this piece separately. Now we have our BNC connector on our coaxial cable hooked into our QFH antenna. Now we're ready to actually get this hooked into our SDR, and let's see if we can pick up a signal. Ha! Yes! It works! It works, it works, it works, it works. Fantastic. Ooh, you beautiful thing, you. Now I need to take everything over to the Raspberry Pi, and then I'll be able to set it up, and then we'll decode these audio signals into satellite images. So here we have the control board and the power supply underneath this shield. This is 12 volts. This is 12 volts and like 3.5 amps. So this should work just fine off of a PC power supply. Oh, again, it's these little guys, these nuts on here. The easiest way I found to take those off is with a 5mm crescent wrench. So little tiny crescent wrenches, good ones are hard to find. These are actually for ignitions, like a car ignition. It's perfect because it has the little 10-degree offset, and it also has like a 90-degree offset. So you can get it into weird little tiny places very easily. Oh, don't chew this up. No, do not strip. Yeah, that is completely stripped out. Don't try this at home, kids. There. So much for the screw. You'd think they'd like not want you to take this thing apart or something. There needs to be a little bit of a standoff for this. Like I need to insulate it. Yes, Mr. Bond. Bond, James Bond. James Bond Jr. Jr. Let it go, Junior. Let it go. Let it go. Okay, so just a quick test fit into the top of the case here. Oh yeah, that's pretty. That is pretty. Now, there's a couple of considerations here. This is a 24-pin connector, and these guys they're a little smart. You actually have to tell it that it's connected to something in order for it to actually turn on. If we were to add any kind of load to this thing on any of the pins, then we will have a problem. and it will just shut down. But what we're going to do, just for regulatory sake, this is a 10 watt, 10 ohm wire wound resistor, and we're just going to put this in line. That is going to give us just a little bit of load to trick the power supply into self-regulating and staying on. And now we know that this thing is going to work. The next step then is to branch all this out onto a power bus so that we can tap into each individual line. When I was a kid, it was always like, kids, get your adults' permission to use the scissors. Oh yeah, guarantee void if removed. Oh well, I guess my guarantees are void. Okay, so a couple of last little things to assemble this thing. I've got to get some acrylic cut so that I can fit the screen into the case. And then I've got this all laid out right here. So this is going to be the top panel. See, I've got it cut there. I've got it just kind of mitered there on the corners so it'll fit nice and snug right there into the case. Some vent holes right here along the left-hand side, a nice big hole for the screen. And then, of course, we need our controls for our screen, our monitor. So we've got these cut out. And what I'll do with these is I'm going to keep these as buttons. So I'll just be able to put those right in place and probably adhere them or some otherwise connect them to these little tack switches that are on the control panel. That's that. Let's get this over to Plasma, get it cut, and let's see what it looks like.
So there's one last element that I need to build, and that's the sort of blinky blinkies that I was referring to earlier. Now for that, I think it would be most appropriate just to put like a little clock module in the corner. I'm going to use these 7-segment displays that I have here and run them off the GPIO on the Raspberry Pi, kind of like we did with Project Moonanite with the asteroid tracker. So let's get this guy set up and we will be in business.
So this is it. Open her up. This is Project Tyros. There's really not much to see yet, because we haven't downloaded any images from the satellites yet. So that's the whole point of this nice heavy-duty weather-resistant case. So we can take this thing, we can stick her up on the roof, leave it out there for a couple of days and see what kind of images we get.
Okay, got our antenna, got Project Tyros ready, and we wait for a pass.
So here it is. This is Project Tyros. This is our self-contained field deployable satellite reception unit. So you see it's built into this nice little case here. You know, the nice Duratool case from Newark Electronics. We've got our monitor here. We can actually do power on the monitor right there. Down here we've got the keyboard. It's fully functional Linux build on top of the Raspberry Pi. So you've got the keyboard here. We have a power indicator for our full mains power, big chunky toggle switch, turn on and off. We've got our UTC clock here to tell us when the satellites are going to be going overhead. And that's really it. Mains power comes in here and is distributed to the bus within that you saw earlier, and everything comes out nice and shiny. If you really wanted to do other things with it, you could, you could install pretty much anything you want on top of it. It is a fully functional laptop type computer, but it just boots up and it gives us our satellite images. It just goes, just pops right into FBI, cycles the available images, and lets us see what kind of cloud cover we have here. This is kind of interesting. You can see this is a darker picture, and you can kind of see the trails of smoke from a couple of fires here in this is like central California. It's not really southern California. Well, that's all the time we have for today. What sorts of RF work have you done? Have you ever tried to build a receiver and download images from a satellite? Let us know in the Element 14 community at element14.com/presents. And until next time, tally ho, y'all. I gotta go pick up some satellite images.